All right, so we're talking about frogs or something here. Oh, dry cell. Dry cell uses paste instead of an electrolyte, and they use so you have a paste, and then of course you can have some sort of metal. What kind of metal do you think there is? Utilizes combinations of different materials. Let's see. There's like zinc. Also good if you have a cold. Zinc, copper, carbon, lithium. Also good if you're depressed. Yep. Ion. I'm not going to write these. Lithium manganese dioxide, nickel oxyhydroxide, silver oxide. Oh, there's all kinds of metals that they're using in them. Yes. Huh?
Lithium ion.
It's a metal?
It's a salt.
I said materials.
Oh, okay.
Thank you for correcting me on that, though. It's appreciated, and the class thanks you too.
Class doesn't know what the hell's going on.
They're back with the frog legs still. So it really doesn't matter what the hell I say up here, Prince. It's almost like a conversation between you and I at this point. So we're even missing a few people who are out looking for frogs right now. If that was true. The one guy at the tool room asking if James had salt. It's all right.
Do you have a brine solution?
All right. Cells may be connected, internal to the battery, that is, connected in series or parallel. Now I feel I should ask, if they're in series, what happens to the voltage? Add voltage. In parallel, what happens?
More amps.
Add amps. Add. Well, my pen got messed up. I don't have any eraser on the other side of my pen here, so it's kind of hard. So yeah, I gotta go here. A lot do. Add voltage. All right. All right, so if we add them in series, we're going to add up and increase the voltage. If we add them in parallel, the voltage stays the same, but you have more amperage capacity. Right. Let's talk about measuring voltage. Now you know why you got stuff wrong. All right, two different measurements. Two different measurements. Two different measurements. What are those two different measurements? Anybody know where I'm going to go with this?
Open, closed.
There you go.
Open versus closed.
Open circuit voltage.
OCD.
Please don't yell out letters while trying to spell. The OCV, open circuit voltage. It is measured with a load or no load?
No load.
No load.
No load. So what happens if you measure with load versus no load?
Well, if we measure it with a load, then it'd be closed circuit voltage.
Well, I'm going to write this, but I can think of why it could be wrong. So that'd be a point of conversation. O is higher than the closed circuit voltage, or CCV. Is it O is higher than the closed circuit voltage?
Yeah.
Well, when would it not be?
Well,
Batteries
if,
will charge.
if it's a battery like in your car that's hooked to an alternator,
Well, it doesn't count because now you hooked it up to an alternator. So,
Maybe when you first hook onto it.
okay, I was thinking, yeah. So maybe when it's brand new battery, but I think if we really looked at, carried the voltage out to several decimal places, we might see that it would be lower. So, in theory, it's always lower than the closed circuit voltage. So there's two different voltages. That's why going back to some of the earlier projects, I didn't count it wrong or mark you against you when I said, okay, what's the total voltage? And you would do it without hooking up to load. I'd just say, well, that's wrong. You got to hook it up to a circuit. Well, that's why you got to hook the load up to it because it changes. So if you're working on your little circuit with your little resistors and your battery's kind of going dead and you do an open circuit voltage check, which means no load, and you put the voltmeter on there, it says like 6.2. Then you hook up the resistors and the LED and everything else, and it drops, right? Okay, so you want in that case you wanted the closed circuit because it would more closely match your circuit, what was going on. Let me see. Is usually not affected by state of charge until the battery is almost completely discharged. Depends on the battery type. So I gotta be careful of that one. Is usually not affected by state of charge until battery is, I don't love this statement, but we're gonna go with it, is obviously discharged. Put somewhat discharged because it's really not true. It depends on the battery type. Some batteries, the voltage, the difference between the open circuit and closed circuit voltage is not going to be very dramatic until the battery is almost completely discharged. And in other types of batteries, you're going to start to see it drop off right away. Justin, you caught up?
Yes.
All
Are
right.
we talking about types as in brands?
What they're made out of.
Gotcha.
can we go back to point number 2 for a second? Just,
A point of conversation.
yeah,
Okay.
that has to be correct because there's no battery without internal resistance.
Yeah. It doesn't always appear that way, though. That was the point.
Okay.
Okay. The other one is closed circuit voltage. Closed circuit voltage, CCV, closed circuit voltage, measured with a load applied. Measured with the load applied. Always less than OCV. Very good, thank you. And that voltage will decrease with an increased load. And that brings me to something called internal resistance.
Funny you mentioned
Or IR. How do you measure the internal resistance of a battery?
Megometer.
it was open circuit voltage minus closed circuit voltage.
Oh, wait a minute. I hear megameter. Okay, and describe that.
It's a really, really big ohm meter that measures really, really massive amounts of resistance.
Yes, we just take an ohm meter and we put it across the battery.
Perfect. That'll go kaput.
It'll go what?
Kaput.
Kaput? How do we measure resistance in the
Is that your
circuit?
phone
Series.
MP3?
What's that?
Is that your phone
No, it's
MP3?
Phil's.
No, that's Phil. You'll learn about that next semester.
Did you want me to get it?
Well, I think it's yours. Phil's on yours.
Phil's phone has
I've got an arm
You don't have to worry about my phone unless you hear Little Mermaid playing. Then I have to go get it because that's my wife. So, all right. How do we measure resistance in a circuit? With what? Applying voltage. So we measure resistance in a circuit. What, hooking up the battery?
No.
No.
Applying voltage from the meter.
Applying voltage from the meter. So I don't use the battery to do that? What happens if I do that? Who has their own voltmeter, ohm meter? Anybody want to volunteer tomorrow? We get out one of the big batteries.
Why not?
And we're gonna-
I volunteered
Might as well use Michelle. She burned hers up this weekend anyway. So what's going to happen to the ohm meter if we put big load on it with a big battery?
It's not going to read anything.
That screen goes black.
Yeah, the screen goes black.
I
Okay.
accidentally tried it because I didn't know that it was live.
So as a reminder, if you have just just joining us, you do not measure ohms with the load applied. So how are you going to get the load off of the battery? I'm sorry. Let me rephrase that. Now nobody confused. You don't measure resistance with power applied. So how are we going to take the power out of the battery?
Take the battery out of the power.
Got to take the battery out of the battery. That's it. We got to drain the battery until it's completely dead. Then put the ohm meter across and go. Well, there's your internal resistance. All right. You kind of have to be careful with this internal resistance thing because it's a little bit misleading. You can't measure it. It's like measuring the resistance of an LED, which if you haven't figured that out, you can't do it very well. So, all right, internal resistance, IR, is the resistance of the battery when connected to a load. Oh, so you got to connect it to a load, then use an ohm meter, right?
Yeah.
Then you're just buying fuses at that point, not a whole new meter.
Is the resistance of the battery when connected to a load. I don't see that there's any real practical value to knowing or dealing with the internal resistance of the battery, other than it's a great thing to have you do in lab to demonstrate Ohm's law. But as far as understanding what the battery's doing, there is some practical value of it. So where am I here? Internal battery connected. So internal resistance equals the open circuit voltage minus the closed circuit voltage. That's the difference between the two voltages divided by amperage, which is kind of like saying there's E, I, and R. So R equals E divided by I. Did I mention this?
No. No, you said you were going to.
I know, yes. So that's Ohm's law. Voltage divided by amps equals resistance. Who would have thunk? I just find this stuff on the interwebs. I don't know what I'm doing. All right, example. So we have a battery, and we measure the battery with no load. What is that called?
Open circuit voltage.
Okay, it's got open circuit voltage of 14 volts. Then I connect a load, and I've got a closed circuit voltage of 12 volts. And it just so happens that there is a current draw of 100 amps. So what is my internal resistance of the battery?
Well, let me tell you, Kevin.
I'm listening.
You can get a 2. You can divide that 2 by 100.
0, 2, 0, 0,
That'd give you a
2.
number. And it's 0.00.
Hey, your calculator's coming out. That's a good thing.
But what if you have a shunt?
You will have a shunt. Want to see how I got that?
300 amps.
Well, let's say this is a relatively good battery in a good state of charge. But after a while, we have the open circuit voltage is still 14, but this time the closed circuit voltage, because the battery is discharged, is only 10 volts. But we have the same load on it, so we still have 100 amps. What's the internal resistance of this somewhat discharged battery now? 0.04 ohms. So we could say that that's point V because
Are you really trying to keep track?
I was trying. Example, this is example 2. Somebody's going to care. Example 2, example 1. That brings me to V, so now everybody's happy. As the battery discharges, the internal resistance goes up or down?
Increases.
Will increase. Now this is an important point here that I want to bring up because this is where it kind of gets confusing, but I'm just going to point it out. So when you're talking about this internal resistance, as I said, I've yet to come across a practical value of this because if you memorize this fact, okay, as a battery discharges, the internal resistance goes up. Therefore, if you have a dead battery and you connect it to a charger, it will take a lot of amps or not many amps. Well, if what I said is true, then that would be true. But who's charged a dead battery before? And what happens when you hook a charger up to a dead battery? What does the amps do? Is it really high or is it really low? It's really high. So wait a minute. If the internal resistance is really high, then why do I have this gigantic draw through it?
You lying to me, Kevin?
Well,
Yeah, I'm listening.
because the
It doesn't have to do with the internal resistance, right?
no.
Okay. So I want to make this point here, not to be confused. Not to be confused with charging resistance. As a dead battery will offer little resistance to a charger. All right, so this is to say that if I have a battery and I'm dealing with open circuit versus closed circuit divided by amperage, and I'm working with the battery in that sense, I have this thing called internal resistance, which I don't know, I wish they'd call it something else. But so the internal resistance goes up. Okay, but let's just put a pin in it. And now let's talk about if I'm going to charge a battery. So I've got a battery out of an airplane or your car or whatever, and it's pretty dead. And I get one of those chargers. And we'll talk about different types of chargers. But this time we'll talk about a constant potential charger, which means if I set the volts to stay the same, the amps will fluctuate. So if I say, all right, I got a 12 volt battery and I'm going to put it on 14 volts the charger and it's dead and I put it on there and I can measure the amps. When I connect it, it's go, whoa, that's a lot of amps going in. And then go away, have a little break, your sandwich, whatever, come back and the battery started to charge and like, well, that's a lot less amps. So as the battery charges, the amps start falling off.
As it gets closer to its total voltage.
As it gets closer to total as it's charging up. And that makes sense if you think about it. It's filling up with electrons and so it starts to die off. But if you try and make that make sense with this internal resistance comment, the two don't match. And you see that? They're not congruent. Yeah.
But I mean, they're completely different things.
That's what I'm saying.
Okay. I mean,
You understood
there
the
is a
point?
use for it. Like you can determine the efficiency of the battery with it, or the wear of the battery, or the heat that it can withstand.
But that's engineering.
Oh, okay.
We're working on a battery.
So why do we need to know?
So as that's my point. That's what I've been saying, Prince. So, all right. So it's important that you don't confuse those two things. Again, as you connect, because as a mechanic, how many times in my career was I asked to calculate the internal resistance of a battery?
0.
That's exactly correct. -1 time probably. So less than that. As a mechanic, how many times did I have to hook a battery up to a charger?
Millions.
Every day.
Every day or twice a day or more times a day. So you want to, and so if you had this whole internal resistance, so you show up, well, let me tell you something a little about batteries. The internal resistance there is going to be pretty high because it's dead. So when I hook up the charger, you're not going to get a lot of amps. You hook up oh, nope, that's wrong. Never mind. My bad.
Your guys' charger's broken.
All right, yeah. You're going to need a new charger. All right, so remember those are two different things. All right. So if I asked you, hey, you hook a dead battery up to a charger on a constant potential charger, which means what is
Constant voltage.
constant voltage, is the amp's going to be high or low when it starts charging?
Won't be
High. And what's the amp's going to do as it charges?
It's
Going to go down. So if I had a battery and I put it on a constant potential charger and I'm looking at it and it's taking 20 amps and I come back after, well, I'm working on my aircraft, so I come back, I've had a couple beers, you come back, you're looking at it, and now it's only taking 0.1 amp, it's charged up, yeah, and so are you, so don't work on your airplane. See how I tied that in? See what I did there? All right.
Just need a couple like that, and you're good to go.
What if that's when you do your best work?
One of these days I'll tell you about the story where I had to go in for a random alcohol check and they came back and told me that my blood alcohol was 0.44. I said, do you think I'd be alive if that was true?
Well, it depends on your state of alcoholism.
They didn't know how to read the test.
Matt blew way higher than that over the weekend.
So half of your blood was alcohol.
Yeah. And so we got another test and I showed him how to do it. And the lady was like, so I guess I'm telling you the story. It was funny because this is like the day before Thanksgiving too. And so there's nobody else in there. And I'm like, that's not how you do it. And so, hey, bring me another one and I'll show you. So I because she left the thing there with the instructions. And so I read it. So let me show you how to do it. So she got another swab. And so I said, okay, it's how you do it. And I go, now do this. Now, okay, now read it like this. She goes, I said, so what's my blood alcohol now? She goes, well, it's nothing. I'm like, exactly. And she goes, wait a minute. She goes, could you do this again for because nobody here knows how to do it. So she brought everybody else in, and I showed them. And I thought that was really cool. They're willing to learn it. But then I asked the question that was the $1 million
How
question.
many people have lost their jobs?
How many of these have you done today? 6. And was anybody sober? No. Well, you have some explaining to do, don't you? All right, lead acid batteries. Also known as, that's what AKA means if you don't know, also known as, what else can we call them? I gave you some other terms.
Car batteries. Airplane batteries?
Just shut up.
Is anybody else besides Dennis that actually, thank you. That was a good try, but not necessarily.
Lithium ion?
You can go with him. Because a lithium ion is a type of material. What kind of material is this battery? Lead and acid. So okay, I'll just tell you.
Thank you.
A storage battery. What does that mean?
Storage.
Storage battery. Didn't I? I mean, I could scroll through here, but I guess I'm pretty sure I mentioned the storage battery. I know I did. And under what? And what kind of cell is that? Okay. And what does secondary cell mean? Rechargeable. So I guess we could look at it like this: a primary cell, not secondary. So primary, meaning first. What was the first cell that they used? The frogs. Okay, it was the frogs. Were the frog legs rechargeable? No, they were not. So that made it a primary cell. Then they came up with rechargeable, which would be the next one, which would be secondary. Okay, so storage batteries. because we can store electrons in them and take them out and then put them back in. So the storage battery. So, my goodness. All right, so a storage battery, which is also, well, I guess that was actually my B point here. So that's a secondary.
Is there at least one question on the test about frog legs? That won't make my day if there.
I might have to rewrite it. I wouldn't want you to be sad.
What was the UG go long as you said?
It would
Yeah.
honestly make my day if that was one.
All right. 2 types of lead acid. There's actually kind of more, but I guess we can kind of lump it into 2 types of lead acid batteries in aviation. And by the way, the FAA is not keeping up with the battery technology
Why not?
because they have to rewrite questions. They have to hire. All right, there's the vented cell.
And they have to do a job.
Which I will say is similar to a car battery. And by that, I mean the old school lead acid batteries. And let me see. They have screwable caps. Screwable caps to allow access to top of cells for servicing. So that makes it what kind of battery? It's a wet cell, right? Vented cell. So it's a wet cell. For sure. All right. Then they have sealed batteries.
Those tend to explode.
There's going to be another type too. All right, sealed batteries. So there's no ports for servicing. Advantage, no acid spills. Right. No acid.
False claim.
False claim right there.
It's all about marketing.
Okay. I will tell you that, so we do have in the shop 3 types of batteries I'm having you work with. There's 2 big black ones that just, well, one of them I think came out of my van. So it's car battery. The other ones came out of somebody's tractor. It's car battery. Then we have the pink gill batteries. And those have the vented caps on top. And those are, you pull the caps off and you service them. We'll talk a little about that. Then we have the Concord batteries. I have 2 Concord batteries. One came out of my aircraft, and I don't know where the other one came from. But they're flat on top, and it looks like there's no servicing. But there's a little plate, and you can see where people have pried it off with a screwdriver. And so you can pop the plate off, and guess what's under the plate? Screwable vent caps.
Yeah.
So the idea is that they don't vent off as much. They kind of expand a little bit more and keep the moisture inside, so they're not supposed to be serviceable. I will tell you the reason why the battery out of my airplane is here is because somebody who will remain nameless, it wasn't me, but his initials were Joe, serviced the battery and noticed it was low and said, oh, it's low, so I should add, what should you add?
Distilled water.
Oh no, we should add some electrolyte because that's what's in it. So he poured straight battery acid into it and then overfilled it, and then under a charge it spewed this stuff out because it'll find a way out, and it did all over the side of the airplane. And so I had to, well, when I bought the airplane, I had to fix that. So, but again, I'm not pointing fingers at anybody. So anyway, so that was really hard on the battery and the airplane. So those are the types. Okay, so talking about these 2, continuing to talk about these 2. Batteries have ratings. There's G, PG, PG-13. All right. Common aircraft. Battery. voltage, ratings, R, ratings, that's an S, ratings, that's just not working out. Ratings are, can't wait to find out.
Right after this.
Yeah, right. Hey, you got your 12 volt.
Get out of town.
I know, didn't see that one coming.
I like 14 better.
Which has, how many cells?
6.
6 cells
Damn, that's a hell of a
connected
goal. In the spring barrel.
in series. Whoever gave him the Red Bull, could you not do that anymore? Which is 12.6 volts OCV. Then you have a 24 volt, which has how many cells? 12 cells. Connected in series. Which gives us 25.2 OCV. So if you had your calculator, how many volts per cell do you get with a lead acid battery? 2?
24 volt?
Well, it should work out the same.
Should be 2.
12.6 divided by 6 is
21.
you should be getting about 2.1, 2.2 volts per cell. All right, so not only do you have to get the right voltage, and what happens if you mess up on that?
What do you mean?
Well, you got a 12 volt battery, 12 volt aircraft, and you decide to use a 24 volt battery.
Oh, you're gonna get a lot of heat.
Start up real
A little bit of
fast.
a boom.
Somebody did that to our poor little Cessna 172,
They fry
and
the whole computer and electrical system.
yeah, that's why it doesn't run very well. So
Somebody did that at work with a 24 volt engine.
yeah.
We're just gonna jump start it. The pickup.
Oh.
Their truck didn't work after that.
Oh yeah. So Joe, the guy I mentioned before, maybe he's a good guy. So I gave him the instruments out of it, and he actually took them all apart and found the microprocessors and rebuilt them for us at no cost. So he redeemed himself. But so pay attention. And the reason why that happens is because a Cessna around here, Cessna 150s, all have 12 volts. A Cessna 152, which looks exactly the same except it has a light coming on the front, is 24 volts. Then you go to 172, at least the older ones, I think all of them are 12 volts. So you have to really pay attention. Then the 310 is 24. The Skymasters, I think, are 12. Vanessa, are they 24? I don't remember now. I always look.
Yeah, it's 24 because we had to share the battery.
Okay, they're 24. The Bonanza's 12. So it goes back and forth, so pay attention. All right, batteries are also rated. Also rated in amp hours. Let me see. I should have more on amp hours here. Oh yeah. Oof, I'll get into it later. So 1 amp hour. 1 amp hour. Amp hour. AH. 1 amp hour is the ability. Is the ability of a battery to deliver 1 amp for 1 hour. Or a combination of, or like 1/2 amp for 2 hours. And we'll talk about this later, but I just want to tell you right now that, all right, so like an aircraft battery, a common thing would be 30 amp hours. So 30 amp hours means,
30 amps per hour.
well, it is supposed to mean 30 amps for 1 hour or 30 amps for 1 hour, but it's not really the case. What they do is they figure out what does it do in 5 hours. So a 30 amp battery will give you how many amps for 5 hours,
30 divided by 4. Or 30 divided by 5.
which is? So it should give you 6 amps for 5 hours. And so they average it or figured out right there about 5 hours. So the truth of it is, if that's true, 1 amp should last you for, according to the sticker, 30 hours, but it doesn't. It's going to last a lot longer. And how many amps could you get for 1 hour? 30, it should, according to the sticker, but it doesn't. You get a lot less than 30. So you see how it's not linear? So if you take a whole bunch at once, you're going to get less. If you drag it out over a longer period of time. So it's actually based on a 5-hour time frame, but I'll make that note like later on when I get into it. All right, construction. I have some vidges. I know, which means I have to